This video accompanies the 2.2 lesson presentation for geometry on parallel lines. Okay, so we want to be able to determine the measures of angles formed when parallel lines are intersected by a transversal. So if you have two lines that are parallel, and we'll mark them parallel, and you have a line that cuts across those two lines, we'll call this line the transversal. And we're going to see that there's something special about the relationships of different pairs of the angles that are formed when two parallel lines are cut by a transversal. So we have theorems that go with that. Let's move on. So this diagram shows two parallel lines that are cut by a transversal. What relationships among the measures of the angles do you see? Well, it appears, we can see that angle 1 and angle 3 have to be congruent because they're vertical angles, but it also appears that angle 1 and angle 6 are actually the same size. It looks like angle 2 and angle 5 match up. Looks like since 2 and 1 are supplementary and 1 and 4 are supplementary, or by vertical angles, angle 4 is the same as 2, which means that 4 is probably the same as 5, which is the same as 8. And then we have vertical angles that tell us that 1 is congruent to 3 and 6 is congruent to 7. So these are some relationships that we can see using vertical angles and linear pairs. Suppose a different transversal intersects the parallel lines. So let's say instead we had a line that cut across like this. Change colors. Would you expect to find the same relationships? But now using the pink line, now this is angle 1, and its vertical angle is there. And this angle 1 appears to be the same size as this angle down here that's formed. And its vertical angle is going to be the same. So it seems as though the relationships are the same. And then we have the linear pairs of angles that make the straight line. So it seems like if you have parallel lines cut by a transversal, there's a pattern about the relationships of the angles that are formed. Okay, let's move on. So what angle relationships are created when parallel lines are intersected by a transversal? We want to identify angle pairs. Let's see. We have angles that we call corresponding angles. And they're, I look at corresponding as same side, same side. So CORR for short, same side, same side. So like using, say, 4 and 8, angle 4 is on this side of the transversal and above one of the parallel lines. And angle 8 is also to the right of the transversal and above the other parallel line. So we say these angles are in corresponding position with each other. We can do the same thing with 5 and 1, with 7 and 3, and with 6 and 2. Like as an example, 6 and 2, if we look at angle 6, it's to the left of the transversal, below the top parallel line, and angle 2 is to the left of the transversal and also below the other parallel line, which is the lower parallel line. So these are in corresponding positions. We have another set of angles that we can talk about that are alternate exterior angles. So angle 8 and angle 2 are on opposite sides. So alternate exterior, AE for short, they're on opposite sides of the transversal and outside the lines that are crossed. So if we look at 2 and 8, they're both on opposite sides of the transversal line, which is this line that cuts down through here, and they're outside the parallel lines. 5 and 3 would also be a pair of alternate exterior angles. Let's move on. Here's our first postulate, postulate 2.1. This should be added to your postulate and theorem list that we started in the section, or in at the end of chapter 1, I think 1.7 maybe. So same side interior angles postulate. If a transversal intersects two parallel lines, then same side interior angles are supplementary. So that means that the measures of these two angles are going to add up to 180 degrees. So let's see, how can we express each of the numbered angles in terms of x? If we look at 2 and x here, 2 and x are a pair of same-side interior angles, so these angles must add up to 180 degrees. Angle 4 and angle 8 are a pair of corresponding angles, and 8 and 6 are a pair of vertical angles. So let's see, by postulate 2.1, angle 2 and the angle with measure x are supplementary. So if we knew what x was, we could subtract it from 180, and we would know what angle 2 would have to be. The angle with measure x and 7 are vertical angles, and 6 and 8 are also vertical angles, which are congruent to each other, but we can see that the x degree angle and 6 would have to add to 180 degrees, and also the x marked angle and 8 would also have to add to 180 degrees because those make a linear pair. So angle 7 is congruent to x because it's a vertical angle with x. It's supplementary to 6. 7 is supplementary to 6 and to 8. Let's see. Angle 2 is also supplementary to x because by the postulate, these two need to add to 180 degrees. Same side interior angles are supplementary. So if 2 is supplementary to x, and if 6 and 8 are both supplementary to x, it must mean that 2 and 6 and 2 and 8 must be congruent to each other by our congruent complements or congruent supplements theorem from the last chapter. Let's move on. Here's our theorem 2.1, which should be added to the list. If a transversal intersects two parallel lines, then alternate interior angles are congruent. So angle 1 is congruent to angle 2 if and only if we have parallel lines intersected by the transversal that makes those two angles. Our theorem 2.2, the corresponding angles theorem, states that if you have parallel lines intersected by a transversal, then the angles that are in corresponding positions, remember corresponding means same side, the corresponding angles are going to be congruent. So 1 and 2 would be congruent. The vertical angles to 1 and 2 would also be congruent to each other. And those would give us in this set of 8 angles that are formed, these would give us the pairs of congruent angles. Let's move on. That also needs to be added to the list. Our theorem 2.3, alternate exterior angles theorem. If we have parallel lines cut by a transversal, alternate exterior angles are congruent. And this kind of comes from, like, 1 is actually congruent to that one, and 2 is actually congruent to this one. And let's see what else we got. With our same side interior angles being supplementary, Same side interior angles are supplementary. This vertical angle is also congruent to it. The dotted angles are both supplementary to this angle, which is the same as angle 1, which means these angles must also be congruent to each other. And these are linear pairs with the angle marked 2 and the angle that's vertical to it, which means that these arc marked angles also have to be congruent to each other. But with this theorem, alternate exterior angles are congruent. If you have parallel lines cut by transversal without having to do any argument, we know that the opposite outside angles, exterior angles, have to be congruent to each other. Let's move on. Here we want to prove here they do prove the alternate interior angles theorem. So let's see what they do here. You've got m parallel to n, which is given. We've used the same side interior angles postulate, which says that angle 1 and angle 3 must add to 180 degrees. They're supplementary. So from supplementary, we have that their measures are equal to 180. We also have that angle 2 and angle 3 are supplementary because they make a linear pair. And then by the transitive property, we can set these two equal to each other. And then when we subtract off the measure of angle 3 using the subtraction property, we end up with the measure of angle 1 equal to the measure of angle 2, which means that since their measures are equal, the angles are congruent to each other. So this gives us that if we have parallel lines cut by transversal, then alternate interior angles are congruent. So these are on opposite sides of the transversal, inside the lines that are crossed. So inside the lines that are crossed, and they're on opposite sides of the transversal. If the lines are parallel, alternate interior angles have to be congruent. Let's move on. And here's our concept summary. Same side interior angles postulate. Same side interior angles are supplementary. Our theorem, alternate interior angles theorem. Alternate sides inside, they're congruent if the lines are parallel. Corresponding angles, same side. If the lines are parallel, these corresponding angles are congruent to each other. And alternate exterior angles, angles that are outside and on opposite sides of the transversal are going to be congruent if you have parallel lines cut by a transversal.